All right, so number 9, we have y plus z, or square root of y plus z in the numerator, square root of y separately, and then plus the square root of z. And then on the bottom, we have the square root of y minus the square root of z. Now, this, we also want to rationalize the denominator. And when we have separate terms, two terms like this, we multiply by what we call the complex conjugate, which just means it's going to be the same term, and this only works when we have square root, and you just change the sign. Okay, if you had like a cube root, you also have to have like a squared or some power to match up to be 3. So what I need to multiply on the bottom is going to be the square root of y plus z, square root of z. And whatever you do to the top, you have to do to the bottom. Or whatever you do to the bottom, you have to do to the top. So you got to do that on both. Square root of y plus the square root of z. So we have to FOIL, and some things come into play. So when you do the bottom, when you multiply by complex conjugate, if you remember the difference of squares formula, if not, I'm going to write it down. Difference of squares says if I had a squared minus b squared, there's the difference, and the squares are a squared and b squared. If you have difference of squares, when you go to factor those, it is equal to a plus b times a minus b. Okay? So if you have a binomial, two terms, being multiplied together, just the opposite sign in the middle, is going to be equal to the squares. Okay? And that's exactly what we have here, just different, looks like a different shape. This y, square root of y, is equivalent to a, and I know they're in different order, but 3 times 2 is the same thing as 2 times 3. So when you multiply, the order doesn't matter. It has the associative property. Commutative property, actually. Okay, so when we multiply these two together, they end up being squares. Remember, squares and square root cancel each other out, right? So at the end of the day, I'm going to end up with a minus b. So I'm going to skip all the middleman and just tell you that when you FOIL these together, it ends up being a minus b squared, these two terms squared, but square and square root cancel each other out. So you end up with y minus z. That's it. Okay, save yourself some work if you use that fact. Now, the top we actually have to FOIL out. Okay, and that's going to be a little bit of work. So we have to multiply square root of y times y. We have to multiply square root of y times the square root of z. And then we have to multiply square root of z times y and the square root of z times the square root of z. So this y goes to both and the z goes to both. Okay? So I'm going to write it down here. I'm going to simplify it, and then I'm going to put it up here in my answer. So square root of y times square root of y is the square root of y squared. Write it all out. That's going to cancel out that square root. We'll do it in a minute. Square root of y times the square root of z is just going to be the square root of y and z. I can't do anything with them. They're different. So I'm done with y. I've done y times both of them. Now I'm going to do z. Square root of z times y, again, is going to be yz. I'm just putting them in alphabetical order so that I can combine them. And then square root of z times square root of z is going to be square root of z squared. So notice how these two are the same. Here's one of them, here's one of them. So I have 2 of these terms. So when I combine these, this just becomes y plus, there's 2 square root of yz's, and then plus z. So you can either write the y and the z out front and then the square root at the back. It doesn't matter. It should all accept. So my answer here, y plus 2 square root y times z plus z. Now, I am trying to remember if the computer makes me do absolute value here because I started out with a square root. I think I should, but I'm going to be lazy and say, what if I don't put them there? Are they going to strike me? They probably are going to strike me, but I'm just going to show you and try it and see. So division bar, I'm going to leave the absolute value bars off. I'm going to pretend that I didn't see it was an even root and just try to put it all in there. Probably going to tell me it's wrong, but we'll see. Plus 2 square root of yz, arrow out, and then plus z. So whenever you do, I must have hit X. So whenever you do square root, you got to arrow over to get out of it, otherwise you'll keep typing underneath. And then on the bottom we had y minus z. So now if it tells me it's wrong, it's because I didn't put absolute value bars, and I'm just trying to check to see what happened. Okay, it took it, actually. So, but most of the time you need them. This was probably a different type of problem that we're focusing on rationalizing instead of the square root property.